All right, so now we are going to take a look at the last three problems. Might as well just combine them all into one video, make it a little bit easier. So if I'm looking at number 15 here, it says find the directrix of the parabola when the given vertex point is 3, -4, and the focus is 5, -4. All right, I'm going to go through and I'm just going to do a really rough sketch of where everything lies, so that way it makes it a little easier for me here. So like I said, rough sketch. I don't know how much more rough you can get here because I cannot even get them to line up straight because I'm trying to use this new little tablet and it's not exactly the easiest thing. But so 1, 2, 3, 4, 5, 6. I know where the 2 points are. I'm going to be down here at -4. So 1, 2, 3, 4. So at 3, 1, 2, 3, -4. That's my vertex. At 5, -4, that's my focus. Now I know that the focus is on the inside, and I know the vertex is part of, the graph. So I'm just, again, real rough sketch. All right, so here is our -3. I don't know where negative came from, but it's positive. And here's +5. Notice how these two are 2 apart. Remember we said before that the definition of a parabola is when they are equidistant, each point is equidistant from both the focus and the directrix. So then if I'm 2 away in here, then I need to be 2 away back here. And that's where my directrix is going to be. Again, we are just dealing with the fact that I'm trying to use this new tool, so it may not look beautiful, and I apologize. Okay, but if I'm 2 away in here, then I am 2 away right here. So then 5 down to 3, down to 1. This is a vertical line, so vertical lines are x equals. So the directrix then is the equation x equals 1. All right, so like I said, I'm going to try to go through and use the same video to do the next 3. So now I'm going to pull up question 16. And here it says, at which of the x values would the graph touch the x-axis but not cross given this particular function? So at which x values would the graph touch the x-axis but not cross? All right, so in other words, when we say touch the x-axis, we're meaning that it's only going to come down and bounce right off of it. All right, and maybe that happens at a couple different places, or maybe it crosses right through. Okay, I'm not too sure with this case because we don't know. We haven't really gone through and checked it. So what we're trying to figure out is what happens at each. So right here, an even exponent makes it do one of these. It makes it bounce, or it just touches. Okay, so here I'm just going to touch the x-axis. Here I'm going to cross the x-axis. And here I'm just going to touch the x-axis again. All right, so now I got to go back up here. At which x values would the graph touch but not cross? All right, so it'll, when this piece here and this piece here, so it will touch the x-axis only at x equaling, well, let's see, what would make this whole function be 0 is when x is 0. And here, what would make this part 0? When x is 6. So that's where it just touches the x-axis and doesn't cross. Okay, so I just wrote right through that, so let's rewrite it. So x is equal to 0, 6. That's where it touches only. Okay? All right, so now let's move to number 17. Here we have another classic example, ones that we've been seeing before, dealing with parabolas. So a basketball is thrown into the air. Its height, h, in feet after t seconds is given by this entire model right here. So again, this is just a model. How long did it take the basketball to reach its highest point, and what is the maximum height of the ball? All right, so if I'm shooting a basketball, again, anybody that knows me knows that I cannot draw for the life of me. So if I shoot a basketball and it's going to come up and eventually it's going to come down right around here, which is my vertex, then that's going to be the amount of time, and then that's going to be the height. All right, so now I need to find the vertex. Well, the nice thing is that this is already set in vertex form. So here is one part of the vertex, here's the other part of the vertex. So in this case, then, my vertex is time and height. The values still come from the same spots, so then that means that my vertex is 3.4, comma 28. I'm not really doing much mathematics here. Actually, I'm not doing any. I'm trying just to interpret what's going on here. So now when we go through and say, all right, well, it's asking how long did it take to reach its highest point? Right here, 3.4. 3.4 what? Well, if you look kind of through the arrows that I have here, 3.4 seconds. What is the maximum height of the ball? Well, it's in feet, I believe, right? In feet, okay? So then it's going to take 28 feet. So in 3.4 seconds, the basketball will reach a maximum height of 28 feet. Okay, and that's literally what I have to write. Will reach a max height of 28 feet. And I'm done. That's it. There's nothing more that you need for that. All right, so in 3.4 seconds, the basketball will reach a max height of 28 feet. There's the entire MCA review. We've gone through everything that you could possibly have on the MCA. I hope that all of these videos were helpful, and we'll make it so that we can do very well on the MCA. All right, thank you, and have a good night.